Hello everyone, welcome back to a new video. In this video, we are going to talk about Kubernetes QoS, which is quality of service. We'll start off with what is Kubernetes quality of service, what are these three different classes, and how are they determined. We'll also do a small practical on how we can create pods with these three different classes and what happens when the node is under pressure and how do pods get evicted or the CPU gets throttled depending upon which class you are using in that particular pod. So let's get started. Let's first start with what is Kubernetes QoS. So it is basically a classification system through which we can create these three classes or pods with these three classes. So the idea is that by the help of QoS, we can determine how the scheduler will prioritize your pods and also how the kubelet will behave when the node will be under pressure for memory or for CPU. For example, if our node has 90% memory utilized, then at this case we would want some pods to be killed, right, or some containers to be killed, but we would not want that to happen randomly, obviously, because we will have different type of applications on our cluster and there should be a sort of priority on which applications should be prioritized with CPU resources and memory resources when the node is under pressure. So this is what we determine using Kubernetes quality of service. So when we are giving our limits and requests to a particular pod, at that point in time, Kubernetes automatically gives either of the three classes to that particular pod based on the requests and limits that are given to that particular pod. So if you're not aware about what are limits and requests, then the idea is limit basically is the maximum amount of resource, either CPU or memory, that a pod can use, and request is the minimum amount of resource that is provided to that particular pod. Let me show you an example. I think I can get a manifest here. Yeah, but limits are not given. So let's create one. Let's call it pod1.yaml. So this is a basic pod which is running just one container, which is Nginx. So if we want to add requests and limits in this particular manifest, we can simply say resources, and then we can define requests, and then we can determine how much memory we would want to allocate to that particular container. Let us say 10 MI for now, and for CPU let's say 2 MI. Similarly, we can define limits. So memory, let us say this is 20 MI, and CPU, let us say 6 MI. So the idea is that requests are the minimum amount of resource that will be provided to that particular container. So for our Nginx container, the scheduler will make sure that 10 MI of memory is provided to this particular pod, to this particular container, and 2 M of CPU is provided to this particular container. And limits is the maximum amount of resources that will be allowed for this container, which is 20 MI of memory. So if this particular container tries to take more than 20 MI of memory, then this container will be killed, which is what we call OOM, out of memory. And if it tries to take more than 6M of CPU, then it will be throttled. So now let's talk about the three classes that we mentioned over here: guaranteed, burstable, and best effort. What are these? Let's first start with guaranteed. In this example itself, let's make it a guaranteed QoS class. How we can do that is we need to make sure that the requests and the limits are the same for the resource. So if the limit is 20 MI, then we'll make sure that the request is also 20 MI for memory and the same for CPU as well. So this is what we called guaranteed class. The idea is that a pod will get guaranteed QoS when every container in that particular pod has the same limits and requests for both CPU as well as for memory. So if there were more containers in this particular pod, then those also should have the limits and the resources to be equal. Now, why is this important? Before that, let's try to deploy this particular pod. So first I'll create a kind cluster. It will take some time. Yeah, the kind cluster is up and running. Yeah, so everything looks like is working fine. Code DNS is still in pending state. Yes, now everything is running. Now let's try to deploy this. Okay, apply-f and the name of the file. Pod created. Okay, get PO. And if we describe this particular pod in Unix, then you will see here that the QoS class is guaranteed. Now, why is this important? Why do we care about this QoS class? The idea is that when this particular node that we created, this particular cluster, this for now has only one node. So when this particular node of this cluster will be under memory pressure or under CPU pressure, then all the pods or all the containers that have this class, guaranteed class, will be prioritized higher, as in they'll be provided with the CPU and the memory that they require. So if, for example, this node suddenly starts using a lot of memory and is out of memory and CPU, then the first pods that will be evicted will be this class, BestEffort, then Burstable, and the highest priority will be given to guaranteed. These guaranteed pods will only be evicted if the system itself is in critical condition. Let me explain you through an example as well. For example, there are 3 pods in this particular node. This is node A. And pod 1 is guaranteed QoS. Let me increase the font. Let's remove this. Yeah. Pod 2 is burstable. And pod 3 is BestEffort. And let us say that this particular node, why am I using this? I need text. Yeah. Let us say this particular node only has 200 MI space remaining. Not space, let's say memory. So now that this node is under pressure, for example, this node had 1 GI of memory and only 200 MI is remaining, then it will make sure that this memory is assigned to pod number 1. If pod number 1 is working fine, then we will go towards pod number 2. And when both of these pods are working fine, only then we'll go towards pod number 3, which is BestEffort. This example will be more clear when we talk about these two classes and how they work. But the idea is the guaranteed class is the highest priority, and then this is lower priority, and this is the lowest priority for kubelet. And how we create guaranteed classes, that the memory, the requests and the limits both should be same, both the memory and the CPU, and that should be for all the containers in that particular pod. Now similarly, let's create another one. Let's call it pod burstable class. We should also change the names. Let's call it guaranteed class pod. Similarly, let's call it burstable class pod. Now what is a burstable QoS pod? So burstable QoS pod is a pod where at least one container will have requests and limits to be different. So if request is 20 MI, let us say limit is 40 MI. If CPU request is 6 MI, then the limit is 12 MI. Or you can also do one more thing. You can just skip the limit part. That is also counted under burstable class. So the idea is that this particular pod is saying that I need 20 MI of memory, but at certain times my memory usage can peak up to 40 MI. So let's accommodate that as well. But I'll not go beyond 40 MI. If I go beyond 40 MI, then you can just do OOM out of memory, and then you can kill that particular container. So if we apply this particular manifest, apply -f, what was the name of the file? Pod burstable class. Yeah. Pod nginx is invalid, I think, because okay, so I see two names over here. I think this is because we didn't change the name of the pod, we changed the name of the container. Okay, so let's update this. Now this is fine. Let's call this container. Yeah, now it should work fine. Okay, apply -f pod burstable class. It has been created. And let's also update the other one. which was guaranteed class. Yeah, so it is not updated, a new one is created. So let's just delete the Nginx one. Yeah, so now this is fine. Let's describe the Burstable class. And you'll see the QoS class is Burstable. The third one is BestEffort. Let me just copy this again. So the idea with BestEffort QoS is that we do not give any resource, we do not give any resource limit or resource requests, which means that the pod is trying to say that whatever memory or CPU is available, I'll take that. I don't want any guarantees. And this also means that when the node will be under pressure, these are the first one that will be evicted. So they do not have any guarantee of CPU that they should get or memory that they should get. So if there is shortage of memory or shortage of CPU resource, then they will not be prioritized. The first one that will be prioritized is guaranteed ones, and then the burstable one, and then whatever CPU and memory is left, this particular type of pod will have to make do with it, the BestEffort class one. So now going back to our example, let us give it particular limits and requests. So let us say request for this was, let's say CPU request 1000 M, right? Let me increase the font a little bit. Yeah. So CPU request for the guaranteed pod was 1000 M. That also means that the CPU limit would also be 1000 M. So let us write that as well. Now for burstable, let's say the request was 500 M and the limit was again 1000 M. Now for BestEffort, we will not define anything. So if this particular pod had, not memory, 4 cores, 4 CPU cores, which is 4000 M CPU. Then since this has taken 1000, this has taken 500 actually. So rest of 2500 will be given to this particular pod. So this pod gets, CPU request would be 2500. Actually, technically, it will not be request, but the CPU allocated or CPU used will be this much. Now, let us say that this node is coming under pressure now. There are multiple other applications also running in this particular node, not just these 3 pods, and they are eating up a lot of CPU. So now only 2000 M CPU is remaining is available. What happens at that case is kubelet will first prioritize this one. So 1000 M of CPU will be given to pod number 1. Now only 1000 remains, right? So that 1000 will be given to the burstable one. And now nothing is remaining. So this particular pod will be evicted. Actually not evicted, because this is CPU we are talking about. So this particular pod will be throttled. So it will not get any CPU. If instead of CPU we were talking about memory, then at that case memory allocation is binary. You either have memory or you do not. So at that case this would have been killed. This particular pod would have been killed with OM error out of memory. But since this is CPU, then none of the CPU is remaining for this. So Kubernetes will throttle this particular pod and it will not be able to run. Now let us say there is more pressure from other resources, and now only 1500 M of CPU is available. Then what will happen is 1000 M will go to the pod 1. So it is running fine still. But now we are only left with 500 M of CPU. So in this case, pod number 2 will also be throttled. So pod number 2 will be slowed down by Kubernetes itself so that it is not able to take more than 500 M of CPU. And then finally, when it is around 1000 M or less than 1000 M, then at that case, we do not have any options. So at that case, pod number 1, which is guaranteed QoS, it will be throttled. So this is the overall idea. I think we didn't apply this particular manifest for BestEffort. So let's do that. Pod, then BestEffort. Yeah. Okay. Describe pod. It was called pod BestEffort, I think. Yes. DS, not YAML. What was the name? Okay. So like you can see, the QoS class would be BestEffort. Now let us try to do one thing. Let's try to simulate this condition where the node will be under pressure. Before that, let's check how much memory has been assigned to this particular cluster. Docker inspect. What is the name of the container? Let's do PS first. So the name is kind control plane. Docker inspect kind control plane, grep memory. It says 0, which basically means that there is no limit set for the memory. So it will keep on growing dynamically as we keep on using more memory in this particular cluster. So let's have a limit for this, because we want to simulate a condition where the memory of that node will be scarce or will be under pressure. For that we will use docker update command. Docker update. Yeah, I think memory is the one. It is in bytes. So I'll have to check how many bytes in 1 GI. Or I think we can also just define 1G here, or GI. Let's see if this works. Otherwise we'll write the exact bytes. And we want swap memory to be 0. So let's say memory swap, also 1 GI. So the RAM will be 1 GI and then memory swap, which is RAM plus swap space, is again 1 GI, so the swap space will become 0. And then the name of the container, which was kind control plane. Let's see if it works. I think it did. If we check memory, it does show this limit, which is, I assume, which is around 1 GI. Let me verify this. Yeah, so this is exactly 1 GI. Now let's move ahead. And now that we have a limit of 1 GI, let's update these pods so that they start using around more than 1 GI. So let's start with guaranteed class pod. What we will do is we will use the stress command from Linux to simulate this condition where this particular pod is eating up that many resources. Let us also update it here. So now node is given, not this, 1 GI memory. So let us say there is pod 1 which is given not CPU but memory of around 200 MI. And since this is guaranteed QoS, limit will also be the same, 200 MI. Let's make the changes here. Firstly, we'll change the image. I don't think Nginx would have stress command, so we'll change it to PU Linux /stress, and now we can add a command. And arguments. So we need only one worker. So one worker which is going to take around, since it is 200 MI, like we said, 200 MI. We'll also update it here. 200 MI, 200 MI. And let's say the worker is using 180 MI of resources, of memory resources. And for how much time? Let's say 3 minutes. Looks good to me. Let's now move to the next pod. So for burstable, not CPU, memory resource should be 200 MI. And the memory limit, let us say 300 MI. And for this one, we'll have nothing. Now for these 3 nodes, it should work fine. There should be no problems. And then later on, we'll bring in one more pod. Pod number 4. And this is where we will take all the memory resources and then we will see how they act. So let's update the burstable one with 200 MI and 300 MI. So the burstable one is 200 MI request and limit will be 300 MI. Again, we will use this particular image. The command will be quite similar. Actually, since it's 200 request and 300 limit, let's say 280. So this is more than the request, but less than the limit. And in this case also, they should not throttle unless we create that pod number 4. So let's move to the best effort one. Let's add some stress here also. Let's say this is, we have how much? We have 180, then we have 280. So let's call it 220. So 220 plus 280 is around 500 mi plus 180, let's call it 150 actually. So this is around 650. So we still have some memory left. Obviously, some memory will be utilized by kubelet and kube API server, etc. for the functioning of the cluster. So even keeping that in consideration, still there will be some memory remaining as of now. Now let's do one thing. Let me create just one YAML file where I can put all of this, so that I don't have to apply it again and again. Burstable one also. And best effort. So guaranteed, burstable, best effort. Okay, get PO. All three of them are running. Let me delete them. Burstable one. Then guarantee one. Okay. Let me just say pod.yaml. Yeah, so it deleted, but it says that there is nothing called burstable class pod, but there was a burstable class pod here. What's wrong? Okay, get pod. Okay, so it is deleted already. Yeah, fine. Yes, so now let's apply this particular manifest. Pod.yaml. So all three of them are created. Let's do k get po. Oh, this is giving error. Let's simultaneously, oh no, I closed it. Sorry for that. I was saying that let's simultaneously also watch the events. And k get po. These are giving error. Let me check logs. I don't think we have to give this. Unrecognized suffix I. Where did I use I? So I have made some mistake, I guess. This is what burstable one, right? So burstable one. Okay, so this should only be M. Yeah, now it should work fine. Okay, apply -f pod.yaml. We'll have to go to that path. Okay, now let's apply it. So apparently we cannot directly update the arguments. So let's just delete it. Or I think I can force it. I don't think it works. Let me just delete it. Okay, delete -f pod.yaml. Okay, get PO. No pods are running. Now let's apply. I don't know what is happening. Why are these pods gone? But anyways, let's focus on this thing. Pod.yaml. Now all of them are created. Yeah, so they are working fine as well. Let me close this. I don't think there is much to understand with events. Let us do one thing. Let us open K9s here. Yeah, this will help us visualize the pod limits. What I see here is there are already restarts for Burstable and BestEffort, which means that our calculation is wrong. Even if we give it, how much load are we putting in? 150, 200, this is 500, 650. So we are putting in 650 MI of memory load, but even that is a stretch for this cluster apparently. And one important thing here is that there is no restart for guaranteed one. Like we said, the highest priority is given to the guaranteed one and then to the burstable one. So we can see lesser amount of restarts here and then the least amount of priority to the best effort one. The solution to this would be to reduce this load. So let's give bare minimum load. This is best effort. Let's say 200. Burstable, let's give it equal to its request. And let's keep it 100. So this is 200. So this now is 100, 200, 500. I hope this is fine now. Otherwise, I'll change again. So I deleted those pods, created them again. Now let's see if the load is fine. Burstable one is also running, guaranteed one is waiting. Here we can see this is the memory compared to the resource limit. So 200 is the memory being used compared to the limit of 300. Let's just verify this. Yes, we gave 200 load and the limit was 300 for burstable. So this looks fine for now. And again, we are seeing OM killed. Let me go back and let me find a number where this will work fine. So I have revised the load that we were giving to the pods. Now this is around 500 MI, actually 400 MI. And for now, this looks fine. Pods are not being OM killed. Yeah, this looks fine. So this is what I wanted to show. We can see that the memory usage is around 200 compared to the limit of 300. And for now, everything is working fine. Yeah, since 2 minutes, it has been running and nothing is dying, so it looks fine. Now what we are going to do is, we are going to add another pod to this, a separate one. Let's call it a villain pod. villain.pod.yaml. Let me copy the burstable one. Let's call it villain pod. Villain container. This should be fine. Since around 600 MI, the node was having issues. So let's try doing that. Since we already have given 400 MI here, let's give 200 MI. Not MI actually, 200 M in this case. Looks good. So now let's add this pod. Villain pod. So the villain pod is being created. And now we will notice which pod will be evicted first once this villain pod is up and running. You can see the first one, which was BestEffort class. This got killed. It got restarted. And now the burstable one got killed. And guaranteed one is still running fine. This is what I wanted to show. When the node will be under stress, then kubelet will first OOM kill the BestEffort class, then the burstable one, and then at the last we will go for the guaranteed class one. So the idea is that the important applications should be part of guaranteed class so that they never fail. Again, you can see this, that this has been restarted. Now this is being restarted, but the guaranteed pod is still working fine. Now again, this will be restarted is what my assumption is. But yeah, the idea is that the highest priority is given to the guaranteed pod, then the burstable class pod, and then the BestEffort pod. So we would want to make sure that all our important applications that we want to make sure that they run even during high node pressure should be under guaranteed class. Like I said, BestEffort one has restarted. And then the second highest priority applications should be part of burstable class. And then I would not really recommend using BestEffort class because it takes away all the resources that are remaining. So even in this example, you would have seen the BestEffort class pod starts running the fastest because it has all the resource to its disposal. Because we are using limited resource here and here, all the rest of the CPU and memory goes to the BestEffort class, which is not an ideal condition. So we can try avoiding best class. This was the overall idea. I hope you were able to understand what these QoS are, quality of service classes are. I hope this video helped you out. If you want to watch more videos on Kubernetes, you can check out this channel. In either case, thank you for watching this one, and I'll see you in the next one.